Good morning, students. How are you all, students? Hope you all are fine. You are in the peak of your health and happiness. Welcome back to your again academic sessions of 9th standard for the academic year 2021. And today we are going to start with your Science and Technology Part 1, Chapter number 11, Reflection of Light. Okay. So children, let's begin our academic sessions. Now first, when we are proceeding towards this chapter, we should know what is light. Okay. So in this video, we are going to focus on the introduction to light. Now, are you able to see this picture? Such a nice greenery, yes, and flowers are blooming everywhere, and we are able to see the tall trees. Okay. So how are you feeling it? I hope you are feeling very nice after looking it. Okay, so you are able to see this. Okay, there are two reasons for that. First of all, we are very lucky that God has blessed us with the vision. Okay, we are able to see. We should thank God that we are having eyesight and we are able to see. And the second reason why you are able to see that we will be discussing while teaching this chapter. Okay, again see this. So how does it look? You are able to recognize these are tall mountains and river is flowing aside. Okay. So children, how we are able to see this? What is the scientific reason? Scientific reason now we are going to study. What is light? Children, light is an agent which gives us information about what is happening in our surroundings. We can enjoy various wonders of nature like sunrise, sunset, rainbows only because there is light. So as you have seen in the previous picture, the picture of the forest, the picture of the mountain, the picture of the river, you were able to see that because of light. Okay, because we are having light, because there is presence of light, you are able to see it. Now see, it is only because of the light that we can see green vegetation, colorful flowers, deep blue skies in the day and shining stars in the night. Okay, so because of light only we are able to see the nature. Because of light you are able to see the nature around you. You are able to see the stars in the sky. You are able to recognize when it's a daytime and when it's a night time. Now, what is the light? Light is actually electromagnetic radiation which causes the sensation of the vision. Okay, because light is having an electromagnetic vision, okay, it causes the sensation of the vision. Light reflects differently from the various surfaces around us. So we have learned that the reflection of flat surface, smooth surface and regular surface, light reflects differently in different surfaces. We have already studied in the previous classes. Okay, so now we are going to focus on light, certain criteria related to light and certain terminologies related to light. Remaining children we are going to look in the next video. Good morning children, welcome back. Now children, in your Science and Technology Part 1, Chapter number 11, Reflection of Light, we are going to study about the next concept, and the concept is about mirror and the types of mirrors. Okay. Now children, here we are first going to study about what is mirror. Okay. So in scientific language, a surface which reflects light and creates clear image is called a mirror. Mirror is a reflecting surface. Mirror is a reflecting surface. Okay. So whenever you stand in front of the mirror, you are able to see your own image. If suppose you are wearing some red colored dress, so obviously in the mirror it would be appearing red only. Okay, so it won't appear green, blue, yellow, orange something. Okay, so mirror is the reflecting surface. Whatever the things are there, as it is reflecting. Then we use various types of mirror in our daily life. So now, can you name some mirrors in your life? Your regular plain mirror, okay? Then second thing, You are having the mirror in your vehicles also. Yes, you are again having a microscope also. We are having the different types of mirrors. So mirrors are used in a day-to-day life, okay, for various purposes. Then mirrors are of two types. First is plane mirror, second is spherical mirror. Now first we are going to focus on the concept of the plane mirror. Okay, so this boy is standing in front of the mirror. Yes. So what are you able to see? What is the mirror showing? It is showing the image of the boy. And what I said it previously, it is showing as it is. The boy is wearing red t-shirt. So mirror is obviously going to reflect back the red color. Okay, the color is not changed in the plane mirror. Then mirrors are used in various activities in our day-to-day life. And how is this mirror made? A mirror is made by coating the black surface of a flat and smooth glass pieces with thin reflecting film of aluminium or silver. Okay, so surface is coated with the film of aluminium or silver, and to protect this reflecting film and to make the side opaque, another coat of substance like lead oxide is given over it. So your plane mirror is again given the layer of lead oxide, and now while this lead oxide is given, to protect the reflecting film and to make the opaque side of the mirror. Okay, so to make it opaque, we are giving the another coat of the lead oxide on the mirror. So this was regarding the plane mirror, children. Regarding spherical mirrors, we are going to study in the next videos. Please go through the videos twice, thrice, and read the content given in the textbook. So whatever your teacher has taught, your concept will be becoming more clear. Good morning, children. Students, now we are proceeding towards the concept about the plane mirror. So plane mirror we have already studied in the previous video, and we are aware that it is one of the type of the mirror. There are two types of mirrors, okay, and in that we are studying in more depth the plane mirror. Okay, so whenever we stand in the front of the mirror in a home, okay, so if your mirror is proper, if it is, it is cleaned, it is proper, it is dust free, it has not broken from anywhere, it's not broken from anywhere, or neither it is very old. Okay, so if your mirror is in good condition, in short I want to say, if your mirror is in good condition, so whenever you stand in the front of the mirror, you will be able to see, okay, yourself. You will be able to see a clear image. Whenever you stand in the front of the mirror which is in a good condition, you will be able to see the clear image of yourself. Okay, so now when we are studying the plane mirror, we are supposed to understand that how an image is formed in a mirror. Okay, so for this thing we have to just consider that any point source is there, any source of light is there. Okay, now when light rays travel in all directions from a source, okay, now here in this diagram you are able to see. Okay, now see, whenever we want to study regarding the plane mirror, we should know certain basic terms. Okay, whenever you are studying about the mirrors, you should know certain terms. Now here in this diagram, two types of rays are shown. Yes, read along with me. Okay, incident ray and second is reflected ray. Okay, so first one is the incident ray. Now I just want to explain you which is ray is known as an incident ray. Suppose the light rays, you are keeping a candle in the front of your mirror at a certain distance. So the light of the mirror, the light of the candle, when it is reaching to the mirror, plane mirror, that is known as an incident ray. Again, when the same light is given back from the mirror or it is reflected back, in short you can say that is known as an incident ray. Okay, reflected ray, sorry, I'm extremely sorry. So the rays of light which fall on the mirror are known as incident rays. Okay, and the rays which are given back from the mirror are known as the reflected rays. Okay, so here in this diagram you are able to see that there is a plane mirror and incident rays are coming from a point source towards the direction of the mirror, whereas the reflected rays are going back again from the surface. Okay, so this is regarding the incident ray and the reflected rays. Now what happens when you stand in the front of the mirror, when you are getting ready to go somewhere, when you or any light source is there in front of the mirror, you keep any object, you keep a burning candle, what happened? So several of these rays fall on the mirror and get reflected and reach our eyes. So how we are able to see? The rays of the light, they fall on the mirror. From mirror surface they are again given back, they reach to our eye surface, and hence we are able to see the image of the object. Okay, now what happens when we go into the depth? We come to know or we feel that the light is coming from a point which is behind the mirror. It appears that the light may come from behind of the mirror, from a point behind the mirror, and hence this point is the image of the point source. That point is the image of the point source. Okay, now see here, figure 11.2a shows light rays falling perpendicular on the mirror and reflected back in a perpendicular direction. This is the diagram of the light rays falling on a mirror. Now remaining about this we are going to study in the next video. Good morning students, welcome back again children. Now we are still continuing with the study of the plane mirror. We are proceeding towards the point. Here we are going to study the certain another concepts regarding the mirror. Children, it will be better, I request you all to open your textbook, okay, and chapter number 11, and please this diagram I am just showing on my screen, 11.2. okay, this diagram 11.2. I just want you all to keep your book open, and as I am reading, I am explaining, kindly go through the diagram. Okay, so it will be easy for you to understand the concept more properly. So figure 11.2b shows a point source O in the front of plane mirror M1 M2. Then incident rays OR1 and OR2 get reflected to the according to the laws of reflection along the path RS, R1 and S1 and R2 and S2. When these reflected rays are examined behind the mirror, they meet at point O1. Okay, now see. Just again I am reading. So 11.2 shows a point O in the front of the mirror M1 and M2. Now this is a mirror. See M1 and M2. Children, one thing always notice that when you are showing the mirror, okay, so you have to always show the M1 and M2, and in between these lines on opposite side, plane side will be as it is opposite side, you have to draw this small lines which they have shown. Okay, so M1 and M2 is the mirror, O is the point, and OR1 and OR2. Okay, here they have given OR1 and OR2 are the incident rays. Okay, and now when they are getting reflected, incident rays, when they are getting reflected, they are forming the two new rays. Okay, and your reflected rays will be R1 S1 and R2 S2. Okay, see this orange rays. Orange rays are given over here. If you want, you can refer the diagram which is given in your textbook. That will be little bit big to you, and you can give the heading. You can label it. Okay, so OR1 and OR2 are the incident rays, and R1 S1, R2 S2 are the reflected rays. Now, when these reflected rays are extended behind the mirror. See, now when these rays are there, if I try to join this rays backward, see, these dotted lines are shown, children, if you are able to see properly. Okay, the dotted lines are shown. So these meet at a certain point, that is the point is O1. Okay, we are labeling that point as an point O1. Now when we see from E, the rays appear to be coming from O1. Now you are able to see this point E. E means the eye. Okay, here E is given as symbol for eye. When we come to the point E, it appears, we just feel, okay, that the rays are coming from the point O1, and other rays starting from O also get reflected and appear to be coming from O1, and hence what is this O1 known? The point O1 is known as the image of the point O. Okay, then now what about these images? Actually, what is happening? If you look towards the diagram, are they exactly coming? Are they exactly meeting from O1? No. So the reflected rays do not meet actually. Hence they are called as virtual image, because they are not meeting at a point. Hence they are called as a virtual image. And the perpendicular distance of the image from the mirror is equal to the perpendicular distance of the source from the mirror. Okay, so the source and mirror and distance of the mirror actual image and the source, they will be at a 90-degree angle. Okay, so children, please go through the videos and refer the textbook simultaneously, so your concepts will be becoming more clear. Remaining things will be looking in the upcoming videos. Good morning, students. Hope you all are fine. Today, children, we are going to proceed towards the next section of your Science and Technology Part 1. We are going to study about the chapter Reflection of Light. So, children, I just want you to give certain time. Please, before watching this videos, keep your textbooks ready with you. And if possible, or I must say, before you once again watch this video, kindly go through the video number 3 and 4. So whatever things I want you to teach you today, your concepts will be more clear. Okay, now, so children, in reflection of light, we are still studying about the plane mirror. Yes, so till now you know the types of mirror, you know the plane mirror, you know the properties of the plane mirror, and in base we have studied about the images. Where is the image found? Point source image of the plane mirror we have seen. Now, so in your fourth video, you have studied, consider any one single object and how its image is formed in the mirror. Now here I am taking, instead of a point source, I am taking a pencil. Now previously we have studied the point O. Okay, now see, just look at this diagram. A pencil is there. Okay, pencil is covering, suppose you can see inside of pencil, you can see the line PQ is also there. If you are able to see its image in the mirror M1, M2 as P1 and Q1. Now, so how is this image formed? If we use an extended source instead of point source, an image is formed of every point of the source, thereby forming an extended image of the whole source. Now in previous video when we have studied, we have taken a point and we have studied how an image of the point is formed. Now here, instead of point, we have taken an object with an extended source. So you are able to see, okay, object PQ is forming the image P dash Q dash. So as shown in figure 11.2, see children, I want you all to be ready with your textbook also. So whatever I am teaching here simultaneously, you can refer the diagrams given in your textbook also. As given in the figure 11.2, see, an extended source PQ is kept in front of mirror M1 and M2. The images of P and Q are formed at point P1 and Q1 respectively. Similarly, images of all points between P and Q are formed between P1 and Q1, resulting in the image P1 Q1 of the entire extended source. Now see, here I just want to teach you a little bit about geometry also. See, you have studied one line, okay? You have studied point, okay? So point is a single point, okay? And when you say a line is having infinite numbers of points. Yes, this you have studied. A line segment is having infinite number of, a segment, a ray, a line, these are having infinite number of points. In the same way, here you can study that the object PQ is forming the image P dash Q dash. But not only the starting and ending of that object, but each and every point of the object, each and every point on that object is forming the image on the another side. And this we can say that it is resulting to formation of P dash Q dash. It is resulting to form the entire extended source, image of the entire extended source. Now children, you should know, now if I keep any object in front of the mirror, suppose if I keep my compass box in the front of the mirror, so the image of the compass box will be same, okay, as the original compass, unless and until the mirror I am using for special different plane mirror. When I am talking in reference to plane mirror, whatever object you are saying, okay, the image formed by the plane mirror is of same size of that of the source. So this one thing you should know, that whenever you are keeping any object in front of the mirror, the image formed is of the same size as that of the original source of the mirror, of the image, sorry. The image of the word appears laterally inverted in the mirror. This is very thing, we know many times we play also games. You can just try to write the alphabets B, D, P, R, okay. So these images will be appearing to be inverted. The image of every point of word is formed behind the mirror at the same distance from the mirror as point itself, okay. So it is image is formed at the same point, and hence it is called as lateral inversion. What it is called as, when you see, just this experiment you can do at home. Now write the alphabet B, P, D, small b, capital B, small d, capital P, and these alphabets if you see, so these are forming the lateral inversions. Now children, if I want to find out how many images are formed, especially when we go in malls and when we go in the trial rooms, we are able to see n number of images, okay. So how it is formed, there is a formula. How it is calculated now, number of images, n means number of images, a means the angle between the mirrors. So if you want to find out, then there is a formula, number of images is equal to 360 divided by the angle between the mirror and minus 1. So this is going to give you the formula for number of images. Children, remaining we are going to continue in our next video. Good morning students. Now children, while continuing with the plane mirror, today again we are going to study some another concept. Here we are going to study the height of the mirror, okay, how an image is formed, okay. Now see, here a woman is standing in front of the mirror. Yes, you are able to see this diagram, yes, and you are able to see the image. Now we are going to study about this only. In order to see the full image of a person standing in front of the mirror, the minimum height of the mirror must be half of the height of the person. Now see, here if you look in this diagram, a girl is standing, okay, a lady is standing in front of the mirror, and just see the mirror's height, okay. It is only the half of the height of the mirror, approximately you can calculate, okay. Every time it is not necessary, but see, in your home also you might be having different types of mirrors. Certain mirrors which we are having generally near your wash basin or something, they may be very small size, some may be very big, which you are having in your dressers and these things. So if you want to see the complete image of a person, means anyone, yourself, anyone, So what should be the height of the mirror, or what length of the mirror you require? So every time it is not necessary that you should have full length mirror. The height of the mirror should be the at least half of the height of the person. Okay. Now these are the certain images which are formed by a plane mirror and the full image of a person. This diagram is given in your textbook. Now we are kindly open the textbook. As I am explaining the content, kindly go through the textbook. So in figure 11.4, you kindly open your textbook so you will be able to understand simultaneously. The point at the top of the head, the eyes, and a point at the feet of the person are indicated by H, E and F respectively. Okay, so here children, you are able to see H, E and F. Okay, then R and S are midpoints of H, E and EF respectively. See here again, I am going to the back page, back slide. R and S are the midpoints. Okay, the mirror PQ is at height of NQ from the ground and is perpendicular to it. PQ is the minimum height of the mirror in order to obtain the full image of the person. Okay, so for this, RP and QS must be perpendicular to the mirror. Then we have to find out why by studying the figure 11.4. Okay, so we have to prove it. So how we are going to prove it? See, minimum height of the mirror is equal to PQ is equal to RS. And here I can write RE. For getting RS, what I can write? RE plus ES. Okay, so because E is the midpoint. So now here what I am going to do, here I am going to divide it. HE plus EF gives me HF, and if I divide it by 2, so I am going to get HE. Here I am just going back. HE, okay, plus EF. Again I am shifting. Okay, if I take half of HE and half of EF, so what I am going to get is equal to half of the height of the person. And this is the required derivation for calculating the height of the mirror required for a person to see the full image. Children, please refer the textbook and read the content, and please watch the videos twice so your concepts will be clear. Okay, please read the lesson and go through the videos once again from the first video so your concepts will be becoming gradually clear. Okay, stay home children, stay safe, have a nice day. Good morning students. Hope you all are enjoying the sessions of science and technology in which we are studying the new concepts related to your light. Okay, so reflection of light we have started, and here we have already completed the types of mirror, that is plane mirror. Okay, we have started with the plane mirror. Now children, today we are going to study about the spherical mirror. I hope you all are very well aware with the properties of the plane mirror. In the same way, now we are going to study the properties and the different uses of the spherical mirror. So children, this is how the spherical mirror is created. Okay, if we cut a rubber ball into two parts as shown in the previous figure, we can see that each of the two parts has two surfaces. So generally the spherical mirror are part of a hollow glass like sphere. Okay, as shown in the figure. In this figure it is shown how generally the spherical mirror is created. Now the inner or outer surface of the part is coated with a shiny substance to produce a spherical mirror. Reflection of light takes place either from its outer or inner surface. Depending upon the reflection of light from outer or inner surface, your spherical mirror is divided into two types, as a concave mirror and a convex mirror. Now, which mirror is known as a concave mirror? The mirror, if the inner surface of spherical mirror is reflecting surface, then it is called a concave mirror. Means when the inner side, when any mirror, it is having the reflecting surface from the inner side, in that condition it will be known as a concave mirror. And the mirror which is having the outer surface as a reflecting surface is called as a convex mirror. So children, now henceforth we will be studying the concave mirror and convex mirrors, uses of concave mirror and uses of convex mirror. But before understanding in depth, you should know that which mirror is known as a concave mirror. The mirror which is having the inner surface as reflecting is known as a concave mirror, and the mirror which is having outer surface as a reflecting surface is known as a convex mirror. Now, depending upon the types of the mirror, convex mirror, concave mirror, these mirrors are used in different purposes, in different uses, that we will be studying in the upcoming videos. Till that children, please watch the videos twice, thrice, read the lesson, and please have a revision of the previous point also, so that whatever we will be studying further, your concepts will be becoming more clear. Good morning children. Children, in your previous video you have studied the mirror, the types of spherical mirror, that is concave mirror and convex mirror. On the basis of the reflecting surface, whether the mirror is reflecting, the inner part is reflecting, or whether the outer part is reflecting, your mirror is divided into concave and convex mirrors. Okay, so now we are going to study here certain terminologies, certain scientific terms which are related to the mirrors. Now children, these are the scientific terms. Whenever a question comes in exam, define these. For the defining these terms, you have to write in the word as it is given in the textbook. You have to use the language which is mentioned in the textbook. We cannot write in our own words. Especially these definitions are to be written as they are given in the textbook. So first term is the pole. What is the pole? Children, I want you all to open your science technology textbook simultaneously. So as I am explaining you from this lesson, simultaneously you can refer your textbook, you can refer the diagram, so you will be understanding the concept more clearly. So pole is the center of the mirror, is called the pole. Okay, the center of the mirror is called the pole. What do you mean by center of curvature? The center of sphere of which mirror is part is called the center of curvature of the mirror. And in your textbook, in the diagram 11.7, the point C is the center of curvature of the mirror. What is the radius of curvature? The radius of the mirror of which the mirror is a part is called the radius of curvature of the mirror. You can refer the diagram, children, simultaneously as I am explaining you. You can refer the diagram, so you will be understanding the concept more clearly. So you can say that the length CP or CA in the figure shows you the radius of curvature of the mirror. Then principal axis. What is the principal axis? The straight line passing through the pole and center of curvature of the mirror is called its principal axis. The straight line which is passing through the pole and the center of curvature of the mirror is called its principal axis. PM is the principal axis of the mirror in the shown figure. And principal focus. What do you mean by principal focus? The incident rays which are parallel to the principal axis of a concave mirror after reflection from the mirror meet at a particular point in front of the mirror on the principal axis. This point F is called the principal focus of a concave mirror. So in case of concave mirror, your principal focus, okay, is in the front of the mirror, okay, is in the front, okay. And in case of convex mirror, the incident rays parallel to the principal axis after reflection appear to come from particular point behind. So in the case of convex mirror, the point is principal mirror is expected or thought to be behind the mirror. Okay, so in concave mirror it is in front of the mirror, and in convex mirror it is behind the mirror. And what do you mean by the focal length? The distance between the pole and the principal focus of the mirror is called its focal length. The distance between pole and the principal focus is called the focal length. Focal length is denoted by a small f. Okay, children. So here we have studied certain terms which are related to your spherical mirrors. Now please revise this term, so whenever a question comes in exams, you have to be confident to write as it is given in the textbook. You can refer the textbook also, and you can learn from the textbooks also. Please read the lessons so your concepts will become more clear by the time passes. Okay, children, stay home, stay safe, and keep studying, children. Have a nice day. Good morning, students. Hope you all are fine. Children, today we are going to study the concept of drawing the reflected rays. So children, there are certain rules and we have to follow the certain methodology for drawing the reflected rays. So here we are going to study about that. Okay, in this diagram you are able to see the reflected plane mirror is there. Okay, and a reflected ray is there. Okay, incident and reflected rays are shown. So how to draw? Now, how do we determine the direction of an incident ray will take after reflection from a spherical mirror? How do we determine now? So children, I request you all to keep your textbooks ready with you. So as I dictate you, as I explain you, you simultaneously follow your textbook, so your concepts will be becoming more clear. So children, in figure 11.8 you can say MN is a spherical mirror and ray AQ is incident on it. Okay, kindly open your textbook. Once again I am showing MN is the mirror. Yes, you are able to see MN is the mirror and ray AQ is incident on it. It is incident ray. And CQ is the radius and therefore is perpendicular to the mirror at point Q. CQ is the radius. Okay, it is radius of the mirror and it is perpendicular, means it's forming a 90-degree angle at point Q. Now, thus the angle AQC, children, you can refer in your textbook also. Angle AQC is the angle of incidence. So now angle AQC is the angle of incidence, and according to laws of reflection, angle of incidence and angle of reflection are of the same measure. So thus while drawing the reflected ray QB, angle CQB must be equal to angle AQC. Okay, so now see children, you know the laws of reflection, that angle of incidence and angle of reflection are the same. So once you determine what is the angle of incidence, then accordingly you have to plot or you have to draw the angle of reflection. We can study the images produced by spherical mirror by drawing the diagrams. Now, a ray diagram is the depiction of path taken by the light rays. Okay, so your ray diagram shows you the path which is taken by the light rays. To draw the diagram, we use the following rules which are based on the laws of reflection. So, see. So there are certain rules, okay, which are based on the laws of reflection. First rule. What is the first rule? If an incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus. Okay, so first rule is if an incident ray is parallel to the principal axis, then the reflected ray passes through the principal focus. Rule number 2, if an incident ray passes through the principal focus of the mirror, the reflected ray is parallel to the principal axis. And the third rule is if an incident ray passes through the center of the curvature of the mirror, the reflected ray traces the same path back. So these are the three rules which we have which are the rules for the drawing the diagram. Okay, we have to use the rules, and on basis of these rules we have to follow the methodology, we have to follow the procedure for drawing the diagrams. Children, please refer your textbook, read the lesson and watch the video as many as time possible, so you will be understanding the concept more properly. Good morning, students. Children, today in your 11th chapter, Reflection of Light, we are going to study about the images formed by a concave mirror. For understanding this concept, a certain activity is recommended, which I am reading aloud. We have to take a candle or glass lamp, 2 cardboard boxes, large cardboard sheet, white paper, concave mirror, and meter rule and wooden block. Okay, so this sort of arrangement you are supposed to do. You have to take a cardboard box, keep a concave mirror, and a meter scale is kept. Now, what we have to do? First, take the cardboard box large enough to hold the candle or a lamp. Then, cut off one side and place the candle inside. So, when we have to cut one side and place the candle inside. Cut an arrow shaped slit from one side so that we get an arrow shaped light source. So properly a source from upside you have to cut so that you will be getting an arrow shape. Whatever shape you want you can make, noise. So then we have to make a screen of size 20 cm by 30 cm by sticking a white paper on the cardboard sheet and set it up vertically with the help of a wooden block. So we have to keep the wooden block and keep this screen upside. Now on the screen we have to fix the mirror vertically on the other cardboard by making a slit on its top surface. Then place the screen near the window and place the mirror in front of it in such a way that the image of the sun or some far away objects clearly seen on the screen. So you can adjust any screen, like suppose if you would have been in a school, you would have adjusted any one of the tree or anything which we can adjust it. We have to measure the distance between the screen and the mirror in this situation, and this distance will be known as the focal length of the mirror. Then set up the experiment as shown in the figure in a dark room and place the mirror near the 0 mark on the meter scale. Place the screen in front of it and place the light source in between the two so that the distance between the mirror and the source is little more than the focal length of the mirror. So distance between source and mirror should be more, and focal length you have calculated in the previous step. Okay. Now obtain a clear image of the source on the screen by moving the screen along the meter scale and perpendicular to it. The image will be inverted and larger than the source, as the image obtained on the screen is the real. Now move the source away from the mirror so that the distance between two is greater than twice the focal length of the mirror. Again we have to make the distance between the object's source from the mirror so that the distance is twice the focal length, and then we have to get a clear image on the screen by moving the screen towards the mirror. This image is inverted and smaller than the object and the real. Okay, so in this way we will be finding this will be setup of your image. Okay, and in this way you will be able to find out the focal length of the concave mirror, image formed by the concave mirror. Okay, children, please watch the videos and go through the textbook, and I will be showing you more reference videos regarding this. Good morning, students. How are you all? I hope you all are doing very fine today. Now children, see, in your chapter number 11, Reflection of Light, we have now started with the images formed by a concave mirror. Okay children, so just a short flashback if I am doing. We have in the light chapter we have first studied the types of mirror, plane mirror and spherical mirror. Then we have studied the difference between the plane mirror and the spherical mirror. Then we have now we have studied certain the criteria for reflection, and now we are studying how images are formed by a concave mirror. Children, I request you all to kindly keep your textbooks ready with you, so that as simultaneously I am explaining, you will be able to refer it, and then you will be able to understand it more properly. So children, as shown in the figure 11.11, an object AB is placed between the focus and the center of the curvature of the concave mirror MN. An incident ray AQ starting from A and going through the focus F becomes parallel to the principal axis after reflection and returns along the QR. The incident ray AS, children kindly refer the diagram as I am speaking, I am explaining. The incident ray AS parallel to the axis after reflection passes through the focus and returns along the path ST. It cuts the reflected ray QR at point A1, and the image of A is formed at the A1. The point B is situated on the principal axis, and so its image will also be on the axis and will directly move above the A1. The image of B is at B dash, B1 you can say, or B dash, and the images of point A1 and B1 will be formed between the points A1 and B1, and thus the image of the object AB is A1 and B1. From this we can see that the object is placed between the focus and the center of the curvature of the mirror. The image is formed beyond the center of the curvature, and this image, now see children, this is something which you should know, that this image is larger than the object and is inverted. As the reflected rays actually cross each other, the image is real and can be obtained on the scene, or it can be seen on the screen. This is regarding the images formed. Then in figure 11.11b, an object AB, if suppose AB is placed between the pole and the focus of the mirror, the incident ray AQ is parallel to the principal axis, and incident ray AS is in the direction joining the A with the curvature. The figure shows how these rays are reflected from the image A1 and B1 of the object. This image is formed behind the mirror and it's erect and larger than the object. As the reflected rays do not actually meet but appear to come together behind the mirror, this image is a virtual type of image. So students, depending upon the position and the type of the image produced by a concave mirror, when an object is placed at different distances from it, it gives the different type of image. And now in this table, in this chart, the summary is given how the images formed by the concave mirrors. How are the images formed by the concave mirror depending upon the position of the object. Now see, for this again I request you all to open your textbooks page, okay, and to kindly refer the diagram. As I am teaching you children, I request you all to refer the diagram. See, now once you are placing the object between pole and the focus, then the position of the image will be behind the mirror, and this image will be, in nature it will be erect and virtual, and it will be magnified. Size will be magnified, means it will be big in the size. Then if you are keeping it at focus, the position of image will be at infinity, and in such situation the image will be inverted and real, and it will be very big, very largely magnified. Okay, it will be very big magnified. If you are keeping between focus and the curvature, then your position of the image will be beyond the center of the curvature, and the nature of the image will be inverted and real, and it will be magnified. Again, if you are keeping it at the curvature, then center of curvature, at that time it will be, position of the image will be at the center of the curvature, the nature will be inverted and real, and the size will be same as that object. But If you keep beyond the center of curvature, position will be obviously between the center of the curvature and focus. This image will be real and inverted, and the size, okay, will be diminished, means you will not be able to see it very properly. And if you are keeping it at very large distance, position of the image will be at focus, and the nature of the image will be real and inverted, and the size will be just a point, means only a small point like size will be visible. You won't be able to distinguish whether it is a image. Okay, so children, please refer the textbook, read the lesson, remaining we will be continuing afterwards. Good morning students. Now children, we are going to study how the images are formed by the convex mirrors. Children, kindly refer the diagram given in the textbook as your teacher is explaining, so your concepts will be becoming more clear. The nature of the image formed by a convex mirror does not depend upon the distance of the object from the mirror. The images are always small, virtual, and than the object and situated behind the mirror. For understanding this, first we should understand the concept of divergence and convergence of light. Okay, now see these two pictures. Okay, in first picture you will come to know that the heads are apart, and in second diagram you are able to know that the heads of the matchstick are coming together. So from this, a short activity is given which you can do at your home, and you can easily understand the convergence and divergence concept. So you have to take first 5 matchsticks from the matchbox. In first you arrange in such a way that their heads come together at a point. And when their head is coming together at a point, it's given in the textbook also and previously image also. At that time you can say that this arrangement of the heads of the matchstick are said to be converged. Means when heads are coming together, it means it is a converged. Now change the arrangement of the sticks in such a way that heads are apart. Such situation is known as the divergence. Okay. Now children, once you have understood the concept of convergence and the divergence, then afterwards we will be studying about the later concept. In your later videos you will be informed about the certain activities. Okay, certain other activities, that how we are going to find whether the mirror is a convex mirror or a concave mirror. Students, please read the lesson, read the textbook, and especially make sure that you are watching the videos, because this will be again helpful for your future reference. Okay, and certain concepts are there which we have studied regarding the terminologies. Kindly read in the textbook also, so your concepts and the technical languages will be very clear for you. And certain definitions for which we have studied, like radius of curvature, principal axis, principal focus, focal length, kindly revise these definitions from time to time. Till that, okay, now children, here we are stopping this video. Remaining we will be continuing in the upcoming lectures. Good morning students. Hope you all are fine and enjoying the sessions which we are conducting. Now children, today in your science and technology part 1, chapter number 11, reflection of light, we are going to study about the concave mirrors. Okay, so now children, as in previous videos we have studied how the images are formed by the concave mirror. Now we are going to study about the certain properties, certain characteristics of concave mirror. So children, as shown in the figure 11.4, that the concave rays it is known as the focusing mirror. And why it is known as the focusing mirror? Because the parallel rays get focused after reflection in this mirror. So once the parallel rays, the rays they get focused on the mirror, and hence the concave mirror is known as a focusing mirror. The size of the image produced by these mirrors can be larger or smaller than the object, depending upon the distance of the object from the mirror. So as we have discussed in the previous video, that the images formed by the concave mirror either may be smaller or may be larger than actual size of the object. Why it is so, or you question will come in your mind that why the images formed by the concave mirror may be larger or smaller than the actual size of the mirror. That is because it totally depends upon the distance of the object from the mirror. See children, the concave mirror and convex mirror are shown over here. Now if you will study these, if you observe this diagram, you may correlate it with the diagram which we have discussed in the previous video, in which you have studied about the convergence and the divergence of the light. Okay, you have studied which mirror is known as a convergent mirror and what is the divergent. Okay, so with the help of this converging and diverging concept, you are here able to understand that about the working principle of concave and convex mirror. A convex mirror is also called a dispersing mirror. This is because, as shown in the diagram previous slide, a parallel rays get dispersed after the reflection in this mirror, and the size of the images produced by these objects is always smaller than the size of the objects. So in convex mirrors, the size of the object is very small as compared to the actual size of the objects. Now children, many times a question may arise in your mind that how you will find out which mirror is a concave mirror or which is a convex. So here we are going to study that how you can determine the difference between concave and convex mirror. So a special mirror which is used for shaving is a concave mirror. When you are keeping this mirror very close to the face, it gives a vertical and larger image of your face. If the same mirror is taken away from your face, the image gets smaller. Hence the mirror which you are using or which you have seen for the shaving purpose is a concave mirror. Okay, then the mirrors which we are using in our cars, motorcycles, the side mirrors which, okay, these mirrors are convex. Now why these mirrors are convex? These mirrors, the image of a face is erect and smaller, but it remains erect but becomes smaller and smaller when the mirror is taken away from the face. So see children, the convex mirrors are your side mirrors which are used during your vehicles, in your vehicles. So why these mirrors are used in the vehicles? A question may arise because you are able to see the object and you are able to see as you go distance away from the object, it becomes smaller and smaller, and hence many number of objects, if behind you many vehicles are there, you will be able to determine n number of vehicles, or as much as the mirror can capture more area. Hence we are using this convex mirrors in the vehicles. Now so what happens, as a result we can see the images of the surroundings also in the mirror, and with the help or with determining the nature of the mirror by studying the images, we can determine whether the mirror is a convex mirror or whether it is a concave mirror. Children, remaining information we will be studying in the upcoming videos. Good morning children. Now children, continuing with your concave and convex mirror, today we are going to study the certain specialities of the mirrors, different types of mirrors. Now when the light rays coming from an object enters our eyes, we can see the object because while passing through the lenses in our eyes, the rays converge and the image of the object forms on the retina of our eye. And the image formed by the light rays actually converging at a point is a real image. So a real image can be obtained on the screen. The image produced by a plane mirror is an virtual image. An image is produced at a point from which the rays reflected light appear to diverge, and this image cannot be obtained on a screen as the rays do not actually meet. When light collects at a point after reflection from a spherical mirror, they are said to be converged. When we want to bring light rays together, a converging light beam is used. Now here we are studying about the application of the lights. Okay, so where we are using the converging mirror, we are using the converging mirror like doctors. Doctors use such a beam to converge light on a tooth, ear, nose, etc. And the equipments which are using on solar energy are also the converging light. Then when light rays starting from a point spread out after reflection by a spherical mirror, the light is said to be diverged. So when we want to light to spread out from a source to diverge, it is used. For example, diverging mirror is used in the street lamps. The street lamps are having the diverging properties, and hence the diverging mirror is used in the street lamp. Children, now in upcoming videos we will be studying about the uses of convex mirrors and concave mirrors. Children, please refer the textbooks, read the lesson properly, because your questions may be asked from the textbooks also, and watch the videos twice and thrice. And please, as the teacher is explaining, keep your textbook open, look at the video and go through the diagrams also simultaneously, so whatever teacher is teaching you will be able to understand it more properly. And remaining we will be coming in this, looking in the upcoming videos. Okay children, please stay home, stay safe and have a nice day. Good morning students, welcome today to your Science and Technology Part 1, Chapter number 11, Reflection of Light. So now children, since we have completed much more part, let us have a quick recap what we have studied in this chapter. In this chapter we have studied about the mirrors, we have studied about the plane mirror, concave mirror and convex mirror. Okay, concave mirror and convex mirror also come in the category of the spherical mirror. We have studied how the images are formed by the concave mirror and what type of images do you get by the convex mirror. Okay, so now we have to study uses of concave mirror as well as uses of convex mirrors. So proceeding towards the chapters, let us first start with the uses of the concave mirror. So children, concave mirrors are used in dental hospitals, in the barber shop. Whenever you visit to a dentist, you see he's checking your tooth with a special type of mirror. That is nothing but that is a concave mirror. So how you can determine if the mirror is concave or convex? If the object is placed between the pole and the focus of the mirror, an erect, virtual and magnified image is obtained. Means the magnified image of the object is obtained with the help of the concave mirror. Then torch and headlamps of a vehicles. So the torch which we are using when there is total darkness, that is nothing, that is a type of a concave mirror. The source of light is kept at the focus of the mirror and thus a parallel beam of the light is obtained. And floodlights. Floodlights means the light which we generally see in stadium, when cricket matches are there, night crickets are there, IPL is going on there, and when you see that even though outside it is complete darkness but the stadium is full of light, there is ample amount of light. Okay, so that is due to the use of floodlights. So the floodlights are nothing but they are made up of the concave mirror, and the source of light is placed a little beyond the center of the curvature of the mirror, and this gives a bright beam of light. Now various equipments which are you working on the solar energy. Okay children, in your 10th standard you will be having one chapter. Okay, in that we are going to study how the photovoltaic cells are there, how the solar energy is harnessed for different purposes. But at present, at this stage, you understand that the equipments which you work or which are utilizing the solar energy, they are having the concave mirrors intact in them. Okay, so what happens when the sun rays get reflected by a concave mirror? It comes together to form a focal plane. Okay, then children, now we will be studying about the uses of the convex mirror. The convex mirror are mostly mirrors which are used in the side of a cars. Okay, so your convex mirrors are nothing but they are used in the side of the cars in the vehicle, so that you can see image from a distance. Okay, and you can cover a large number of area. And the big mirrors which are fitted in the shops. Big convex mirrors are fitted in the shop. So these are the uses of the concave mirrors and the convex mirrors. Now proceeding towards the next section, here there is a Cartesian signs and conventions. These are certain rules which you have to follow when you are drawing a convex mirror or concave mirror. There are certain signs and symbols. So here you are able to see it is a plane, okay, x-axis and y-axis. So if we study the coordinate geometry, you will be getting a x-axis and y-axis, and different coordinates are there, positive coordinates as well as the negative coordinates. So now we are going to study the sign conventional which we are using for drawing the mirror images. Okay, so first of the sign conventions are: the object is always kept on the left side of the mirror. Suppose if you are drawing a mirror, your object will always be kept on the left side of the mirror. All the distances parallel to the principal axis are measured from pole of the mirror, and we have studied in the previous videos. We are very clear with the definition of the pole. Okay, so now no need to again explain you all these things. The distance measured between the towards the pole of the taken are positive, while the distance measured towards the left are taken to be negative. The distance which are vertically upward from the principal axis are positive, while the distances which are down toward the principal axis are negative. And children, the fifth point, kindly note, and I hope if your textbooks are there with you, underline in that, the focal length of a concave mirror is negative, while the focal length of a convex mirror is positive. Okay, so these are the certain conventions, signs and symbols which you should know when you are drawing the ray diagrams or when you are drawing the mirror diagrams and images. Okay, remaining we will be studying in the upcoming videos. Good morning children once again. So children, now we have proceeded towards the end of our chapter, reflection of light. Now today we are going to study about the mirror formula. Here children, we have to get corrected values of distance by using Cartesian sign convention. The object distance is the distance of object from the pole, while the image distance, V, is the image from the pole, distance of image from the pole. The relationship between the object distance, image distance and the focal length is called the mirror formula. So here we have to study about the mirror formula. What does the mirror formula says? Mirror formula says that 1 upon V is plus 1 upon U is equal to 1 upon F. This formula is valid for all spherical mirrors from all positions of objects under all circumstances. Now, we have to see children, magnification due to spherical mirrors. What do you mean by magnification? Magnification means any object. When you see, now see, we have visited biology lab. Okay, a single object which you are keeping under microscope, that object you are not able to see if you just imagine the Spirogyra. You have studied in your science 2 Spirogyra. Okay, it's not visible, its cell wall is not visible with your open eyes. But when you keep it under the microscope, you are able to see it. So what's the reason you are able to see? That is because of the magnification. Okay, so if you want to calculate the magnification of any object, there is a formula. And what's the formula? The formula goes height of the image divided by height of the object. That is equal to h2 upon h1. So the height of the image is V and height of the object is U. Therefore your formula will be m is equal to minus V upon U. As the object is always kept above the principal axis, its height is always taken to be positive. For virtual images, the height is positive, while for the real images, the height is negative. Now children, let's solve a solved example. Okay, let's solve an example. Let me read the question for you. Rajeshri wants to get an inverted image of height 5 cm of an object kept at the distance of 30 cm from a concave mirror. The focal length of the mirror is 10 cm. At what distance from the mirror should she place the screen, and what will be the type of image and what is the height of the object? Okay. So now first we have to write as per the numerical rule that first you have to write the given. Okay. So children, in your formula what's given? Focal length is given, that is f is equal to minus 10 cm. Object distance is u minus 30 cm. Height of the image h2 is minus 5 cm. Image distance we have to calculate, and we have to calculate the height of the object. Okay. So according to mirror formula, what's the mirror formula? 1 upon v plus 1 upon u is equal to 1 upon f. So the known quantities are, yes, f and u. So now what I am going to do, in your second step, I am going to interchange the position of the quantities or dignities given in the formula. So here I am going to write down now 1 upon v is equal to 1 upon f minus 1 upon u. Now since the value of f is given, so here I am going to insert the given values. In third step I will be writing 1 upon v is equal to 1 upon minus 10 minus 1 upon minus 30. Okay. Now we all know the formula to equalize the denominator. We'll be equalizing the denominator and then we'll be getting the value 1 upon v is equal to minus 3 plus 1 upon 30. Now, so calculating these values, after calculating these values, I am getting 1 upon v is equal to minus 2 upon 30. If I reduce this, I'll be getting 1 upon v is equal to 1 upon minus 15. Okay, and by reciprocal I am getting now v is equal to minus 15. So this minus 15 is the distance where Rajeshri has to keep the screen. So Rajeshri has to place the screen 15 cm to the left of the mirror. Then the next part I have to calculate the magnification. Okay, so here I have to calculate the magnification, and magnification, my formula is h2 upon h1, that is also equal to minus v upon u. So here h1 it's unknown, so I have to calculate h1 is equal to u h2 upon v. Okay, then h1 is equal to, now I am going to put the values in that. I am going to put the correct values, that is equal to h1 is equal to minus, in bracket, minus 30 minus 5, multiplication of both this, divided by minus 15. After calculating this equation, I am getting the values, because 15 ones are 15 and 15 twos are 30. So any number, if it is in denominator, it's only 1. So now I am having the value for h1 is equal to, in bracket, minus 2, bracket complete, multiplied by minus 5, bracket complete. Okay. So minus 2 multiplied by minus 5, I am getting 10 centimeters. So h1, the height of the object is 10 centimeter, and thus we can say that the image will be real and diminished. Okay children, here your chapter gets over. I will be sending the notes to you all. Kindly complete the notes and read the chapter. Bye. Have a nice day. Stay home students. Stay safe. Bye. Take care.